Welcome back to Mathlete's Corner, everybody. In this video, we are going to be looking at the objectively hardest problem on the 2024 AMC 10B, and that was problem 15. The problem reads, a list of 9 real numbers consists of 1, 2.2, 3.2, 5.2, 6.2, and 7, as well as x, y, and z, with x less than or equal to y less than or equal to z. The range of the list is 7, and the mean and the median are both positive integers. How many ordered triples xyz are possible? So let's first get a hold of all the information we possibly can. So our range is 7. Well, if our maximum is 7, then our minimum would have to be x. But instead, if our minimum was 1, our maximum, which is z, would have to be 8. Or otherwise, we could have x plus 7 is equal to z. So that's just one piece of information that we have. Then we're given that the mean is a positive integer. And we know the formula for mean, so let's plug it right in. And when we do that, we get 24.8, which is the sum of our constants here, plus x plus y plus z, all over 9. Now our maximum possible value for x plus y plus z is just when all of them are 8, which is 24. That gives us a maximum of 48.8 over 9. But since our mean is a positive integer, we know that the numerator has to be a multiple of 9. So that means it can be 27, it can be 36, or it can be 45. And for each of those values, we get x plus y plus z as 2.2, 11.2, and 20.2. Now let's look at each of these cases separately. First, let's rewrite all of our integers. So 1, 2.2, 3.2, 5.2, 6.2, 7. All right, now it's these along with x, y, and z. Now, what we can immediately notice is if x, y, and z add up to 2.2, there's no way any one of them can be the median, meaning that our median cannot possibly be a positive integer. So that gets rid of that case. Now let's examine 11.2. We can notice that the mean of x, y, and z is around 3 to 4, which also happens to be around the center of these 6 integers. This tells us that y is probably going to be our median, which means x will be less than the median and z will be greater than the median. So y will be between 3.2 and 5.2. So we can split into two cases because the only two integers between 3.2 and 5.2 are 4 and 5. Now, if y equals 5, we have an obvious solution with x equals 0 and z equal to 6.2, and this satisfies all the conditions of the problem. Now, if y equals 4, this is a little more tricky, because if we say z is equal to 7.2 and x equals 0, well, then our range exceeds 7. So for that reason, we need to look for any other solutions we can find with y equals 4, meaning that x cannot be equal to 0. So let's rewrite what we already know in terms of equations. So we have x plus 7 equals z, and x plus y plus z equals 11.2. Well, we know y is 4, so when we do that, we just get x plus z equals 7.2. Now, when we solve this system of equations, we get x equals 0.1 and z equals 7.1, and that's another solution. So now that we've tackled the 11.2 case, let's try inspecting the 20.2 case. So we can notice that in this case, our values of x, y, and z are going to be fairly large, meaning that we can say z is equal to 8. So let's maybe move a little bit to the right, and we say z is equal to 8. So at this point, we know that x plus y has to be 12.2. Now, if we say that y and z are somewhere on the larger end, then our median, which has to be x, will fall right in between this 5.2 and 6.2. And that means that our only possible value of x in this case is 6. So since x plus y we know from before has to be 12.2, it follows that y is equal to 6.2. And our exhaustive approach has found all possible solutions for a total of 3 solutions. That's all for this video. Thank you for watching. Don't forget to hit that like and subscribe button, and we'll see you next time here at Mathlete's Corner.